This video is for Section 2.2 normal distributions. So in this video, we'll be discussing the normal curve and the normal distributions and their characteristics. So all normal curves have the same overall shape, and that shape is symmetric, single-peaked, and bell-shaped. And so basically the normal curve is going to look like this. So you have your x-axis, and then you would have your normal curve. Any specific normal curve is completely described by giving its mean, mu, and its standard deviation, sigma. So we have talked about mean before, and so when we talked about mean, we let mean be x bar, and when we talked about standard deviation, we denoted it by s sub x. But those were both for the sample mean and a sample standard deviation. And so when we are talking about the normal curve, we're going to be talking about the population mean. My cookies are ready. So you're talking about the population mean, which is mu, and population standard deviation, which we're going to denote as sigma. Now we've talked a little bit about a sigma before, but we talked about sigma as being this E shape that meant for summation. This is a capital sigma, this is a lowercase sigma. So when we're talking about population standard deviation, we're going to let it be lowercase sigma. The mean is located at the center of a symmetric curve, so we know that it's symmetric, which means its mean and its median are the same thing. So your mean would be here, or your median would be here, and that would be mu, and changing mu without changing sigma moves the normal curve along the horizontal axis without changing its spread. So this means changing the mean without changing the standard deviation moves the normal curve along the horizontal axis without changing its spread. The standard deviation, sigma, controls the spread of a normal curve. Curves with a larger standard deviations are more spread out. Normal distribution and normal curve. A normal distribution is described by a normal density curve. We talked about the density curve already. The density curve is a curve that has an area of 1 underneath it. Any particular normal distribution is completely specified by two numbers, its mean and its standard deviation, which we've already sort of talked about. Sorry, y'all, I had to put my cookies on. All right. The standard deviation is the distance from the center of the change of curvature points on either side. And the mean of a normal distribution is the center of the symmetric normal curve, which we've already talked about. We abbreviate the normal distribution with mean, which is mu, and standard deviation, which is sigma, as being capital N, which is going to stand for normal, and then parentheses with mu, comma, sigma. The empirical rule has to do with distributions, with a distribution and observations that fall within that distribution. And so we sometimes will refer to the empirical rule as the 68, 95, 99.7 rule. And so basically what it means is this is only true in a normal distribution. So whenever you have a mean of mu and a standard deviation of sigma. Approximately 68% of the observations fall within one standard deviation of the mean mu. And so basically this is only with a normal distribution. So what it's going to look like is you would have your normal curve, and in the center would be your mean, which in this case is mu, and then you would have one standard deviation, and then you would have two standard deviations, and then you would have three standard deviations. And of course my drawing is a little off, and you guys will notice that throughout the video, that mine are not going to be exactly perfect, but you'll get the idea. Alright, so with the empirical rule, we said that 68% of the observations fall within one standard deviation of the mean. So that means that this is one standard deviation to the left, Oh, bless. This is one standard deviation to the left, and this is one standard deviation to the right. And basically, there are 68% of the observations that fall within this group. So from here to here is going to account for 68% of everything that's happening. Now, approximately 95% of the observations fall within 2 standard deviations of the mean. So here's 2 standard deviations away on the right, and here is 2 standard deviations away on the left. And basically, anything that falls between here and here is going to account for 95%. And then we have 3 standard deviations here and over here. And so 3 standard deviations away from the mean on either side. Is going to account for 99.7% of the observations. Now remember that this is only true with the normal curve. And you'll often hear it referred to as 68, 95, 99.7 rule. All right, so in the next example, we are going to have the distribution of Iowa Test of Basic Skills, ITBS, vocabulary scores for 7th grade students in Gary, Indiana. And we know that it's close to normal. So approximately what that means is that the distribution is going to look like the normal curve. My pen gets really slow on this uphill right here. See? Oh, hey, not that time. Okay, anyway, so we've got our normal curve there, and it says suppose that the distribution is exactly normal with the mean mu equal to 6.84 and a standard deviation sigma equal to 1.55. These are the mean and standard deviation of the 947 actual scores. So it says in part A, sketch a normal density curve that has a distribution of test scores. Label the points that are 1, 2, and 3 standard deviations away from the mean. All right, so in there it told us that the mean is 6.84, and because we know it's normal, that means that 6.84 is in the middle. And then it tells us that we want to find 1, 2, and 3 standard deviations away from that mean, and it tells us that the standard deviation is 1.55. So what I would do to get one standard deviation on either side, on the right side, I would say, okay, I'm going to do 6.84, and I'm going to add to it 1.55. And so one standard deviation away from the mean on the right side would be 8.39. To get one standard deviation away on the left side, we would say 6.84 minus 1.55 to get 5.29. To get 2 standard deviations away on the right side, I would say, okay, now I'm going to do 6.84, and I'm going to add to it 2 times 1.55. And whenever I do that, I get 9.94. So 2 standard deviations away is 9.94. 2 standard deviations away on the left side, I would do the same thing, but I'm going to subtract this time instead of add. So I'm going to say 6.84 minus 2 times 1.55 to get 3.74 for 2 standard deviations away on the left side. And then I would do 3 standard deviations away on the left and the right. And so to get that, I would say 6.84 minus 3 times 1.55, which is 2.19 on the left side. So 2.19 on the left side. And the right side, I would say 6.84 plus 3.155 to get 11.49. So this is approximately what mine looks like, although my normal curve is a little sad looking. So for B, it says what percent of ITBS vocabulary scores are less than 3.74? And then show your work. So if we were trying to find out the vocabulary scores that were less than 3.74, 3.74 would be right here. And so we would say, okay, we know that 3.74 is 2 standard deviations below the mean. So what we could do is we could say by the 68, 95, 99.7 rule, about 95% of the scores are between 2 standard deviations away. So basically from here to here is going to be 95% of the scores. So what that means is, because underneath the whole curve would represent 100%, that would mean that there would be 5% that was left unaccounted for. So that 5% would represent the rest of this under the curve right here. I'm going to highlight it so you can see it. So it would represent all of this, and it would also represent all of this. And so the yellow parts would add up to be 5%. So what we would basically have to do is we would have to say, okay, I know that there's 5% that's not accounted for, and so I would take 5% and divide it by 2 and get 2.5%. So what that means is there's 2.5% that is below or more than 2 standard deviations away from the mean on the left side, and 2.5% that is more than 2 standard deviations away on the right side. What we are concerned about is the left side, though, so we would say 2.5%. All right, C says what percent of the scores are between 5.29 and 9.94. My cookies are officially done. All right, so what we would do is, for one, I'm going to draw another normal curve so that I can kind of see this one a little bit better since I wrote all over this one up here. So I'm going to draw basically the same picture. And I'm going to label everything the same because all my standard deviations and, of course, my mean would be the same. Okay, now I want to find the scores that are between 5.29, and mine is like super way off. Let me change this. No, still bad. Let's start from here. Oh, woo! Okay. All right, deal with it. So we are finding the scores that are between here and here. And so what we have to do for that is we're going to say we see that this 5.29 is 1 standard deviation away. So we have an idea that 1 standard deviation away on the left and the right is going to be 68%. So all of this is 68%. That doesn't account for this little piece over here. What we do know, though, is this 9.94 is 2 standard deviations away from the mean. And so what we know from that is anything that's 2 standard deviations away from the mean on either side is going to account for 95% of all the scores. So basically what we are missing is, we know from here to here is 68%, but we're missing this piece right here. So we need to find out what this piece right here is. Now, altogether, this and this and this over here is all going to represent 95%. I already know that the middle part is 68%. What I'm missing is, I don't know how much this is, and I don't know how much this is. I know that these two things have to be equal to each other, though, because they take up the same amount of space, even though my picture does not, obviously. But they are the same amount of space because altogether this is 95%. So what I'm going to do is I'm going to take 95%, which is the whole thing right here, And I'm going to subtract out the 68% that I know is accounted for in the middle, 1 standard deviation away. So I'm going to say 95 minus 68, and I get 27. Now 27% is what makes up both of these parts added together. So what I have to do then is I have to take 27% and I have to divide it by 2 to figure out how much of these little parts equal. So I'm going to say 27 divided by 2 gives me 13.5. So what that means is this part is 13.5% and this part is 13.5%. Now the only one that I'm actually worried about though is anything from this line over. So basically I am worried about all of this right here. So what I need to do is I need to take the 68% that I know is here in the middle, and I need to add to it this 13.5% because that is 2 standard deviations away on the right, which is the direction I needed to go. And I'm going to add them together. And whenever I do that, I'm going to get 81.5%. So there are 81.5% of the test scores that fall between 5.29 and 9.94. So check your understanding. The distribution of heights of young women between or aged 18 to 24 is approximately in 64.5, 2.5. What that means is approximately normal with a mean of 64.5 and a standard deviation of 2.5. So the first thing we want to do is sketch a normal density curve for the distribution of young women's heights and label the points 1, 2, and 3 standard deviations away from the mean. So for number 1, we would have our normal curve. And on our normal curve, in the center of that would be our mean, which is 64.5. And then 1 standard deviation away on either side, 2 standard deviations away on either side, and then 3 standard deviations away on either side. To get the ones that are, or to get 1 standard deviation away on the right side, what we would do is we would say 64.5, and we're going to add to it 2.5, which gives us 67. To get 1 standard deviation away on the left side, we would say 64.5 minus 2.5 and get 62. To get 2 standard deviations away on the right side, we would say 64.5 plus 2 times 2.5, which would be 69.5. And then 2 standard deviations away on the left side would be 64.5 minus 2 times 2.5, which would be 59.5. Three standard deviations away on the left would look like 64.5 plus 3 times 2.5, which would be 72. And then on the left-hand side, we would say 64.5 minus 3 times 2.5, which would be 57. Number 2 says, what percent of young women have heights greater than 67 inches? So what you would need to do, because 67 inches would be here, is you would basically be finding everything that fell into this region. What you would need to do for that is you would say 67 inches is 1 standard deviation away from the mean. So I know that anything that's 1 standard deviation away from the mean is between 62 and 67, and that would be 68% of everything that you were talking about. What I can say is that everything underneath that curve is 1. And so I know that because I know that a normal curve, everything underneath that density curve is 1. So what I'm going to do is I'm going to say 1 subtract 0.68 because I'm going to change this into a decimal. So 0.68 would represent the 68%, and I'm going to subtract it from 1 because 1 represents the whole. So when I do that, I get 0.32. 0.32 is going to represent this. 0.32 is going to represent this and this. So basically anything that is not the 68% that's in the middle. I'm only concerned about this. So what I need to do is I need to say 0.32 is going to be the blue parts added together. So to get one of the blue parts, I know that these blue parts are going to be equal to each other because it's a normal curve and everything is symmetric. So I'm going to say 0.32 divided by 2 to give me one of the blue parts. And so that would be 0.16, which if I turned it into a percent would be 16%. So basically this part is 16% and this part would be 16%. The only one that we're worried about though is anything that's greater than 67. So your answer is 67% or 16%. Number 3 says, what percent of young women have heights between 62 and 72 inches? All right, so because I drew all over this one, I'm going to draw another one. Make it look exactly or as close to exactly the same as I can. In the middle, everything stays the same across the bottom. And I want to find the percent of young women who have heights between 62 and 72. So there's 62 and 72 is way over here. So basically I want all of this. So I want to know what percentage this accounts for. Well, I know that 62 is 1 standard deviation away from the mean. And I know anything that lies within 1 standard deviation of the mean is 68%. I know that 72 is 3 standard deviations away from the mean. So because I have 3 standard deviations away from the mean, what that means is from here to here is 99.7%. Now I know that this middle part in the green is 68%. So what I can say is 99.7% minus 68% would give me anything that fell into this region or this region. So I'm going to say 99.7 minus 68, and that gets me 31.7. So 31.7% is not accounted for right now. I know the middle part is 68%. I don't know any of this. Now, that represents this part and also this part. So what I'm going to need to do is take that 31.7% and divide it by 2. When I do that, 31.7 divided by 2 gives me 15.85. So what that means is this part is 15.85 and this part is 15.85. Now the only one that I'm worried about is over here because that was part of the shaded region that I wanted. So what I'm going to do is I know I'm going to have that 15.85 and I'm going to have to add to it the 68 that I already had for 1 standard deviation away. When I do that, I say 68 plus 15.85, and that gives us 83.85. Which is approximately 84%, which would be our answer. Alright, so the standard normal distribution is a distribution with a mean of 0 and a standard deviation of 1. So what you have been doing is just a normal distribution, and your mean and your standard deviation could kind of change depending on what the circumstances were of your problem. With a standard normal distribution, your mean, which is your mu, is equal to 0, and your standard deviation, which is sigma, is equal to 1. If a variable x has any normal distribution, and remember we represent normal distributions like this with mu and then sigma, which is the mean and the standard deviation, then the standardized variable z equals x minus mu over sigma. This is the same thing as a z-score, which is what you guys calculated in section 2.1. And so what this means is your observation minus your mean over your standard deviation, just like you did in the last section. One thing that we do with the standard normal distribution or standard normal curve is we find the area underneath that curve. And so what we have for that is I printed out for you back at the beginning of the semester a light pink sheet that had a table that had just a bunch of numbers on it, and it kind of looks like a mess. And I laminated that for you so that you would have it for this very day. So this, even though it looks like a mess, is really kind of easy to understand, and it will be very helpful for you whenever you are trying to find tables or areas underneath the standard normal curve. The big thing about the numbers that you see on that table is they are the area to the left of whatever you looked up on the table. So you are going to look up what z is, and you are going to get the area that corresponds to that particular number on the table. So I'm going to show you an example of that with this problem. Find the proportion of observations from the standard normal distribution that are between negative 1.25 and 0.81. So basically, if you think about that, what you have is you have the standard normal curve with your mean of 0 and your standard deviation of 1. So every time you go away from the mean, it's by 1. And you are trying to find the observations that fall between negative 1.25, which would be somewhere like maybe in here, and 0.81, which would be maybe somewhere in here. So you are basically trying to find this area. Now that area, you could say, is made up of 0.81, so to the left of 0.81, and to the right of negative 1.25. So I'm going to draw those separately so you can kind of get an idea about what I mean. So this would be 0.81. Now what you're going to do is you are going to refer back to your table, so that light pink paper, and you are going to I don't have one pulled up, so I'm having to Google one. But you are going to go to that table, and you are going to look for 0.8 in the left-hand side and 0.1 across the top. Those are negative. Alright, give me a second. I'm trying to find a good one. This will work. Okay, so the way that you read this, Lord, if you can read that. You have a column that says Z at the top, and you have these like decimals over here to the side. And so you're going to find the one that you need, which is 0.8. Across the top, you see 0.00, 0.01, 0.02, and so on and so forth, all the way to 0.09. What you're going to do is you're going to find where 0.8 meets up with 0.01, because if I put together 0.8 and 0.01, it would be 0.81, which is what I need. So what I do is I line up where 0.8 would be and where 0.01 would be, and it would be right here. That number tells me that the area underneath the curve at 0.81 is going to be 0.710. So this is 0.7910. Alright, now we're going to do this one a little bit differently than what we normally do. And that is only because we are trying to find a very specific number. So this is for when you have, this was for 0.81. We are going to do now the -1.25. So there's 0, and there's -1, and there's -2, and we would need this. And we're going to do this one a little bit backwards from what we would normally do. But think about if we wanted to find this. This is a part that is included in this picture, but not in this one up here. So this is everything that's to the left of -1.25. And so, as you can tell, it's included here, but it's not included here. Alright, so what you're going to want to do, if you go back to your table and you're looking at the same side that you were looking at, all of these numbers are positive. So what you're going to need to do is flip over your standard normal table, and you're going to want to look at the negative numbers. So here I am looking at the negative numbers, and I'm going to go to -1.2, and this is still showing you up at the top. It still shows you that this is to the left. So I'm going to go to -1.2, and I'm going to find where -1.2 lines up with 0.05. So -1.2 lines up with 0.05 right here at 0.1056. So this area is 0.1056. Now keep in mind we discussed how this area was included in this one, but not included in this one. So what I can do is I can take this 0.7910 and subtract out 0.1056, and that would give me everything that was included in this region up here that we discussed. So I would say 0.7910 minus 0.1056, and that gives me 0.6854, which would be my answer. So check your understanding. It says use table A in the back of the book. Obviously, you do not have a back of the book, and your table A is that light pink sheet that I gave you at the beginning of the year laminated. So you're going to use that table to find the proportion of observations from a standard normal distribution that fall in each of the following regions. In each case, sketch a standard normal curve and shade the area representing the region. So for number 1, you want to find the area of the curve less than 1.39. So here is your standard normal with a mean of 0, and a standard deviation of 1. And you want to find 1.39. So you basically want to find less than halfway between 1 and 2. So somewhere in here, and you want to find what is this area. So the way that you would do that is you would go to your table and you would locate on the positive side 1.39. So looking at the positive side, you would go to 1.3 and you go all the way over to 9 and you get 9177. So this area is 0.9177. For number 2, you want to find everything to the right of negative 2.15. So it tells you that you have a standard normal. And so what you have is close to negative 2, and you basically want to get everything to the right of that because it says greater than. So that would be basically all of this. Now keep in mind that we said that that table represented everything that was to the left. And so whenever you go to the right, you've got to do something just a little bit different. Whenever you go to the right, instead of just looking on your table, you're going to say 1 minus whatever that you get from the table for that number. So you are at negative 2.15. So you need to go to your negative side of your table, and you're going to go to negative 2.1, and you're going to go over to where 5 is, and you see that it's 0.0158. So you're going to say 1 minus 0.0158. So whenever you do that, 1 minus 0.0158, you get 0.9842. So this area is 0.9842. All right, for 3, you want to get everything that is between negative 0.56 and 1.81. So you're going to have your standard normal. And you want to get negative 0.56. So somewhere like in here. And you want to get 1.81. So somewhere that's like here. And you basically want to find all of this. Now I've showed you how to do it on the table. Now I want to show you how to do it on the calculator. So on the calculator, what you're going to do is you're going to go pull up your calculator. And you're going to go to second, bars, which is distribution. I want you to scroll over to draw and shade normal. So shade normal means that we are going to, it's going to graph for us what it looks like on the graph, and it's also going to tell us the area. So we're going to do shade normal. For our lower bound, it's going to be the lowest thing that we want, which is negative 0.56. And our upper bound is going to be the highest thing that we want, so 1.81. Your mean, of course, is 0. Your standard deviation, of course, is 1 because it is a standard normal. So then I'm going to go down to here to draw, and I'm going to hit draw. And I don't think that y'all says draw. I think that you would just hit enter for that. But we'll look at that together in class to be sure. All right, so whenever you do that, you get a picture of what it looks like, which is sort of similar to what I drew over here. And it tells you that the area is 0.677112. You could have also done this from the table though. And the way that you would do that is you would find everything that was to the left of that 1.81 and then subtract out everything that was to the left of the negative 0.56. And so what I mean by that is you would go to your table, go to the positive side and look up 1.81. So you would need to go to 1.8. 1.81 would be 0.9649. Is it a 4? I think it's 4. So 0.9649. There's an extra little dot that looks misleading. Go away. Hey, there's your chapter 1 test. And then you would subtract out anything that was to the left of the negative 0.56. So it would be like this one that we did over here, where you had this part that was included here, but definitely not included here. So then you would need to go find everything to the left of negative 0.56. So you would go to your table, go to negative 5 or 0.5, go over to 0.56, which would be 0.2877. And whenever you did that, it would work out and give you 0.6772, which is approximately the same answer that we get here. Either way is fine. Do whichever one you prefer. All right, number 4 says use table A to find value x from the standard normal distribution that satisfies each of the following conditions. In each case, sketch a standard normal curve with your value of x marked on the axis. All right, so for number 4, you would have your standard normal curve. You would have a mean of 0 because it's a standard normal. You would have a 1, 2, 3, -1, -2, -3. All right, you have to find the 20th percentile. So in order for you to find the percentile, what you are going to need to do is you are basically going to work a little bit backwards. So 20th percentile means 20%. And so 20% would be approximately 2 or 0.20. So you're going to work backwards, and you are going to go on the table on your positive side, and you're going to start with your positive side, kind of scroll through that and look and see if you see any that get close to 0.20. And so if you're kind of looking through that, the lowest thing we have is 0, 0, which is 0.5. So it might be good for us to look at the negative side. So if we look at the negative side, then we would be looking for 0.20. So I can see that in here I have 0.2119, and then I have 0.2090, still a little bit high, still a little bit high, but here I have 0.2005, which is pretty close to 20%. So then what I would do is I would look and see that that is at negative 0.84. So what I would have is that my z-score, or my z, would be at negative 0.84, which is like here. And that would be all of this. So basically, this line is at negative 0.84. So whenever you're given a percentile and you need to work backwards, you are going to look on the table for whatever is close to that percent as a decimal, and then locate your z from that. On number 5, it says 45% of all observations are greater than z. So we start out with our standard normal. So 45% would be 0.45, and we would go find that on our standard normal table, or a curve, which would be right here. And we would be looking at all the observations that were greater than that. So basically all of this. Now if you think about it, if we're talking about 45% of the observations are greater than that, then we would be talking about 55% were less than that. And remember that when we talked about percentiles, percentiles have to do with the percentage that is below that. So we're talking about really the 55th percentile. So what we could do is, if we know that this represents the 55th percentile, we could really go to our table and we could find where we were at 0.55. And so if we're looking through here, closest thing to 0.55 would be 0.5517, which is about 0.13. So this would be 0.13. How to solve problems involving normal distribution. So the first thing that you need to do in our 4-step plan is that you need to state. So you're going to state or express the problem in terms of the observed variable x. So basically tell what x is equal to. The second thing you're going to do is plan. So you're going to draw a picture of the distribution and show the area of interest under the curve, which is what we've been doing on all of these examples. The third step is to do, so you're going to perform the calculation. So you're going to standardize x, basically find the z, and then you are going to use the table and the fact that the total area under the curve is 1 to find the required area under the standard normal curve. And the last thing you're going to do is conclude or write your conclusions in the text of the problem. So for this example, this example is about Tiger Woods, and it says on the driving range, Tiger Woods practices his swing with a particular club by hitting many, many balls. When Tiger hits his driver, the distance the ball travels follows a normal distribution with a mean of 304 yards and a standard deviation of 8 yards. What percent of Tiger's drives travel at least 290 yards? So the first thing we're going to do is state. So what we are going to state is what our x is equal to. And so for this one, we're going to let x be the distance Tigers golf balls travel. And you might want to say the variable has a normal distribution with a mean of 304 and a standard deviation of 8. And you want to say we want the proportion of Tiger's drives where x is greater than or equal to 290. The next step is to plan. So when we plan, we're going to draw out what it looks like. So we would have our normal curve. And on our normal curve, the mean for this one is 304. and the standard deviation is 8. So what we would say is 304 plus 8 would get us one standard deviation, which is 312 on the right side. And 304 minus 8 would get us 296 on the left side. And we could do that several times. So two distributions, or two standard deviations away from the mean would be 320. 3 standard deviations away would be 328. 2 standard deviations away on the left side would be 288. And 280 would be 3 standard deviations away. Now what we want is when x is greater than or equal to 290. So we want to go a little bit past this 288, and we basically want all of this. Alright, for the do step. So we've done 1 and then 2, now we're on 3. So for do, what you need to do first is to standardize. When we standardize, what we mean is get the z-score. And so the way that we do that is we say z is equal to x minus the mu over the standard deviation. So that would be 290 minus 304 over 8. 290 minus 304 over 8 would give us negative 1.75. So that means that when x is greater than or equal to 290, that corresponds to when z is greater than or equal to negative 1.75. So what we found is this right here is x is equal to 290 and z is equal to negative 1.75. And this is all under the normal curve. So now that we have standardized and we know what our z is, we want to look at the table. So when we look at the table, on the table what you're going to do is you are going to see the proportion of observations that is less than negative 1.75. So you're going to go to your table, and you are going to go to the left or smaller than negative 1.75. So I need to be on the negative. I'm going to go to negative 1.7 and go over to where 5 is, and that would be 0.0401. That would basically be all of this. So 0.4041. And so that means that approximately 4% of his drives travel less than 290 yards. So if we wanted to find anything greater than or equal to 290 yards, what we would have to say is that entire curve is 1. So we would say 1 minus 0.04, or 4%. And what we would get is 0.96, which is approximately 96%. So what that means is from here all the way over represents 96% of our observations. And so the last part is to conclude. And when we conclude, we basically say just that. So we're going to say about 96% of Tiger Woods drives on the range travel at least 290 feet, or 290 yards. All right, another example has to do with cholesterol in young boys. So this time we are going to use Table A or the standard normal table in reverse. So it tells us that high levels of cholesterol in the blood increase the risk of heart disease. For 14-year-old boys, the distribution of blood cholesterol is approximately normal with a mean of 170 milligrams of cholesterol per deciliter of blood. And so it gives you that conversion here, mg over dl. And the standard deviation sigma is equal to 30 milligrams per deciliter. What is the first quartile of the distribution of blood cholesterol? So the first thing we have to do is we have to state. So when we state, we are going to talk about basically what our X is. And so for this one, we're going to call cholesterol levels X. And so basically X equals cholesterol levels. You're going to say this variable, which is normal, has a mean of 170 and a standard deviation of 30. And then it tells you that you want the first quartile. Now we know that the first quartile is the value with 25% of the distribution to the left. So we would say that the first quartile is the value of X with 25% of the distribution to the left. The next step is to plan. For the plan, you are going to draw a normal curve with an area of 25%. So if you think about it, 25%, and the reason we're doing 25% is because we're talking about the first quartile. So 25% would be something close to this. So what we would do is we would need to go to our table and we would find where we have 0.25. So on our negatives, and I go to my negatives because if I go to my positives, all these numbers are much bigger than 0.25. So I would go to my negatives, and 0.25 would be maybe negative 6.9. Actually, it might be better to be at negative 6.7. Yeah, that's better. So at negative 6.7, we've got 0.254. So approximately this would be our Z, and Z would be at less than Actually, z would be at negative 0.67. That doesn't tell us what x is, though. So we would still need to figure that out. So for the do, the first thing we would do for this one, because we already have the area under the table, we would need to, we know that z is the negative 0.67. So what we would need to do is we would need to get our z-score, or our x, which is what we need. We already have our z-score. So what we would need to do is kind of go backwards from what we would typically do. So typically to get our z, we would say x minus the mean over the standard deviation. But what we already have is we know what the mean is, and that is 170. And we know what the standard deviation is, and that's 30, and we know that z is negative 0.67. So basically, we would solve this equation for x. So the first thing we would do is multiply both sides by 30 so that we could get rid of the fraction, and we would say 30 times 0.67 would be negative 20.1 equals x minus 170. We would add 170 to both sides. And when we add 170 to both sides, what we end up with is 170 minus 20.1, which would be 149.9. So 149.9 would be equal to x. And so our 21st, or the first percentile or quartile, would be 149.9. So the last part we need to do is conclude. And so what we do to conclude is we basically tell what our answer means. And so what our answer means is the first quartile of blood cholesterol levels for 14-year-old boys is about 150 milligrams per deciliter. And the reason I said 150 is because it was 149.9, so I just round up. Check your understanding. Follow the method shown in the examples. To answer the following questions, use your calculator or the normal curve applet to check your answers. So for number 1, it says cholesterol levels above 240 milligrams per deciliter may require medical attention. What percent of 14-year-old boys have more than 240 milligrams per deciliter of cholesterol? Alright, so if we needed to calculate the percent of boys that have more than 240 milligrams per deciliter of cholesterol, the first thing we would need to do is we would need to get the z-score. So to get the z-score, we would say our observation would be 240. We know that our mean is 170, and we know that our standard deviation is 30. So we would say 240 minus 170 over 30. When we do that, we get 2.33. So then what we need is we're thinking about the picture. We know 170 is here. We know our standard deviation is 30. So if we're looking at the curve, this is about what we have. And we want to know what percent have more than 240. So 240 would be somewhere here. And we basically want to know, what is this? the area here. So we know that our z-score for that would be 2.33. And we know that that's to the left. So what we're going to do is we're going to say the whole thing is 1, and we're going to subtract out our area that we would find under our curve in that part. So what we would need to do is we would need to go to the positive side, and we would go to 2.33. So that would be 2.30, 2.31, 2.32, and 2.33. And so that would be, we would subtract 0.9901 from 1. And when we do that, we get 0.0099. So what percent of boys have more than 240 milligrams per deciliter of cholesterol? In order to turn this into a percent, we would need to jump our decimal 2 times, and so we would get 0.99%. So very, very small percentage. For 2, it says people with cholesterol levels between 200 and 240 milligrams per deciliter are considered are at considerable risk for heart disease. What percent of 14-year-old boys have blood cholesterol between 200 and 240 milligrams per deciliter? So I think it's easier on this one probably to use the calculator. So I would go to the calculator, and I know it's normal, so I'm going to do second bars for distribution. I'm going to go to draw so that I can see what this actually looks like. Shade normal. My lower bound is going to be 200. My upper bound is going to be 240. My mean, I'm going to change to 170. And my standard deviation, I'm going to change to 30. And then I'm going to go to draw. Whenever I do that, this is what I see. I can click on it to get my area. And my area would be 0.14884. So what that means is the percent of 14-year-old boys that fall within that range is 0.41488. And if you wanted to convert that to a decimal or to a percent, it would be 14.88%. What distance would a ball have to travel to be at the 80th percentile of Tiger Woods' drive lengths? So if we're talking about the 80th percentile, what that means is that 80% of the drive lengths are less than the 80th percentile. So what we would need to do to be less than would be to the left side of the 80th percent. And so what we would need to do is we would need to locate 0.80 on our table. So looking at my table, I would try to find where I had the closest thing to 0.80. So we have 0.7795, we have 0.8023, and so 0.7795 is closer than 0.8023. So that 0.7795 is at 0.8 and 0.04, so 0.84. So what that means is the Z for 80th percentile would be 0.84. And so knowing that the Z is 0.84, I know that my z-score is set up by saying 0.84 equals my observation minus my mean, which in our Tiger Woods example, the mean was 304, the standard deviation was 8. So x minus 304 over the standard deviation, which is 8. And this one I would need to solve for x, so I'm going to multiply both sides by 8. And whenever I do that, those cancel. I have 8 times 0.84, which is 6.72, equals x minus 304. To get x by itself, I would add 304 to both sides. And whenever I do that, 6.72 plus 304 gives us 310.72 for x. So what that means is that the ball would have to travel 310.72 yards to be at the 80th percentile.